Okay. Go ahead. Question? Before we start, guys?
Like, does this mean that we can't solve it at all like we did the last one?
We cannot solve this like we did the last one because I've got multiple trig functions in play. The previous problem, when you look at the problem that's given right here, I have one trig function I'm working at, which is tangent.
Right.
So get tangent by itself, which we did down here.
Can't you divide the sine out?
Ah! Looking at this, yeah, you have a real temptation right out of the bat to divide both sides by sine.
Oh, hold on.
But, ladies, what if sine of x happened to be 0, and I just divided both sides of the equation by it?
Then you're screwed.
Dividing by 0 causes a rift in space-time and risks life as we know it in this universe collapsing upon itself.
But it didn't collapse, so it's not 0.
That's because we haven't done it yet.
But I did it.
Well, then we all count our blessings that your division did not end the universe as we know it. At least not this particular universe.
You can't divide
Yeah,
by sine.
you can. Unfortunately, guys, never divide both sides by sine, cosine, or tangent. Never do that. You don't know if sine, cosine, or tangent are going to be 0, so you can't divide it out.
So make it into cosecant and multiply by cosecant.
What I can do, funny.
Wait, so how come in our past unit, the one that you guys just took a BA over, you could have divided like both top and bottom by?
You were dividing top and bottom of a fraction by stuff. You were factoring things out. That's different than trying to balance an equation than dividing by 0. It's a different habit. It really goes to this idea. I can write an untrue statement like 6 equals 5, divide both sides by 0. I get undefined equals undefined, which is true. What I'm going to do with this instead, ladies, is bring everybody to one side of the equal sign. So I have 2 sine x cosine x minus root 3 sine x. All of that equaling 0. My goal is to use that zero product property. So now I can factor out of sine x, leaving me 2 cosine x minus root 3 equaling 0. And if you remember back from algebra 1, if a product equals 0, one of the two factors has to equal 0. So that gives me sine x equals 0 or 2 cosine x minus root 3 equals 0. And those are both equations that I should be comfortable with solving at this point.
Nope.
Well, sine x equals 0. That happens fairly simply. Let's see. X, therefore, is the inverse sine
Hey, we're root 3 over 2.
of 0.
Cosine of it, and that's on the unit circle.
Right. Funny how that works.
Yeah.
So sine, let's see, inverse sine of 0, 0 happens. Sine is y, so it's going to be at 0 or at pi.
But it
Or 2
can't
pi.
be because of the ASTC. Or no, because of the restrictions.
Right.
Okay.
And if I'm restricted by, since sine is restricted to just, if it's a function, my only answer is 0. And if I'm going to use this rolling answer with integers, based on the way the pattern's set up, I would write my answer as n pi, where n equals an integer.
Wait, why would it be 0 then? What would it be so
If I'm limiting my answer to functions, the sine inverse function
Because then it has to go on the
has to be
other one.
between negative pi halves and positive pi halves. 0 will be the only answer that works off that unit circle.
Okay.
Wait, why doesn't pi or 2 pi work? Oh, just never mind.
Right. If that's assuming I'm working off the function. Yes?
What are your restrictions for sine again over?
Sine as a function, the inverse sine, is limited to negative pi halves to positive pi halves, quadrants 1 and 4, which is why my answer is only 0, because positive pi, negative pi, 2 pi, all those are outside that initial range. Generally speaking, though, guys, this answer here is what I'm most worried about coming up with. Shoot.
Why isn't it 2 and
Because it's happening at 0, then pi, then 2 pi, then 3 pi. Sine hits 0 every time it crosses the x-axis. So it happens every pi in the intervals. Now I still have to solve this fella for a list of possible answers. This goes to what we just practiced with tangent. Add root 3 to both sides, so 2 cosine x equals root 3. Cosine x equals root 3 halves. And therefore, x is inverse cosine root 3 halves. And that's another one that we recognize from the unit circle. We're going to try to keep these easy for you once you get to this stage, so we don't spend a lot of time dealing with those inverses and weird, unfamiliar fractions with the radians and stuff. You'll also notice we tend to have answers that are in radians.
Oh, that's nice.
Cosine, those are my x values. And pi, I think that's going to be, nope, not there and there. It's going to be there and, oops, there for my answers, right? Because it's a positive. So that means I've got pi thirds and negative pi thirds as two answers.
Wait, I thought it was pi 6. Pi 6.
Pi 6, negative pi 6.
Pi sixths?
Yeah.
30 degrees.
Cosine's the x value.
At 30 degrees.
Oh, yeah, you're
pi
right.
6. Come on, O-Dog.
This is what I get, yeah, that's what I have written down too. That's what I get for not looking at my notes.
6.
I did that twice, didn't I?
Are you recording?
Yeah. That's okay. Nobody watches them anyways.
I'll watch it.
It depends on what title you
Yeah, apparently I need to, I should write Justin Bieber teaches pre-calc and get lots of hits then. Now, so that's a couple of answers. I also need to consider, guys, if I want, guys, hey, guys, if I want just from using a function, my only answer would be this. And lastly, I should also be able to write this in interval notation. I'm going to write that up here. So I would write pi sixths plus 2n pi and negative pi sixths also plus 2n pi.
Wait, but why can we only use pi 6, the positive, and why do you only circle that?
Okay, you gotta hang tight. Back up. Question?
Wait, but why
Must
did
not be a
you
hint
only
video.
circle or square pi 6? You said we can use this one, whereas like pi 6 and negative pi 6, it's in the negative pi halves and pi halves.
Oh. You could write this answer down too. Going all the way around. So instead of negative pi sixths, you could write 5 pi, no,
It'd be 11.
11 pi
But that
sixths.
doesn't work because it has to be between negative pi halves and pi halves.
That's okay though.
But what?
Here's why. When we're writing down all the answers, we're generating these equations that are going to kick out all the possible answers as we rotate through integers. Then it doesn't matter if I write negative pi sixths or 11 pi sixths plus 2 pi n, because I'm still going to generate the same values as it rotates.
Okay.
Because think about it. Negative pi sixths plus 2 pi lands me at 11 pi sixths.
But then why couldn't we have 2 pi for the other one?
I could, but this one, it rotates every pi. So that means that n pi is still going to kick out every answer for every integer I plug in. Not quite there? We'll practice it a little bit more. For now, I would say, based on this introduction today, if you can get to this point here and to this point here, the points where you're giving me the within 1 unit circle worth, that's a good start.
Yeah, it's just